Evaluating expressions in Python is a little more complicated than we've sort of let on in the last video tutorial. So we're going to go into more depth about two things: precedence and Boolean expressions that have comparisons. So let's start. We talked about order of precedence. We didn't give a table, but so you can use this table as a guideline, and you can see the order of precedence when you have expressions. So, for instance, you can see here that exponentiation is very high in the order of precedence, and then a unary plus or minus to make plus and minus numbers. Normal multiplication, division, as well as the remainder and modulus arithmetic all work at the same level. Addition and subtraction. And then here we have comparisons: greater than, equal to. You'll find that for the Boolean operations, the not, and or, they don't all work at the same level. So you'll find that a not has a higher precedence than an and function, and an and function has a higher precedence than or. You can almost think of and as being the equivalent of multiplication and or the equivalent of addition. Now, we talked the other day about the and function and the or function, and if I have two inputs, we find that in the and function, if I have true, and if this is true, this is the only time that this is true. So P and Q is true when both the inputs are true. And for an or function, as long as one of the inputs is true, it evaluates true. Otherwise, it evaluates false. So those are the basic operations, and of course not just inverts the logic. So if I have not and I have false, not false is just true, and not true is just false. So that seems very straightforward. However, there are times when we're going to try to evaluate things which aren't obvious. How do I do a comparison between true and a number 2? True equal true. It doesn't seem to make sense. Or 6 and true. So what happens in these operations require a deeper understanding of how Python handles true and false and comparisons. So let's look at our float collection of our float class, or collection of float numbers. We'll draw that as a big set with a circle here. And we'll say that the integers are just a simpler or a subset of the floats. So I have my ints in here. So an integer is simply a float that doesn't have a decimal point. And we'll further describe Boolean or bools as a subset of integers. So a bool is just an integer that has a certain value, and we're going to find out what that means in a second here. So what happens here if we have true and we have then a comparison to 2? The comparison operator expects numbers on both sides that it can compare. And this is true of greater than, or less than, or not equal to, any of the comparison operators. So yes, we have a number on one side, but here we don't have a number. We have true and false. So what happens? How does Python handle this when we have true and false? Well, false, if it needs to be evaluated as a number, evaluates to 0, and true, if it needs to be evaluated, evaluates to 1. So what we have here is 1 equal, it's going to do a comparison with 2, is 1 equal to 2, and its comparison operator wants numbers here, but it gives a true and false answer, so it's going to give the answer false. And if we look at our little shell here, it did that. So that's how Python handles that. Ands and ors, when we have a mixture of numbers and true and false, can be a little more complicated to understand, but what we've got to do is understand how Python's handling the operation of ands and ors. So if we have false ORed with 3, how does Python handle that? Well, when we do an OR operation, think of Python as comparing the OR between two expressions here. What Python does is it evaluates each expression, and it can evaluate it as true and false, but it can also evaluate it as a number and then interpret it as true or false. So here, Python evaluates false as false, doesn't need to evaluate it as a number. Now, it's an OR function, so Python continues because from this side, it's false. The other side could be true, and if it is, then the whole expression is true, because in an OR function, just one side has to be true. So it goes to the other side, and it looks at 3, and it needs to interpret 3 as being true or false. How does it interpret it? Well, it interprets this way. If the number is 0, that's interpreted as false. If the number is anything else, it interprets it as true. So 3 is evaluated to the number 3. It's interpreted as a true. So what we have is a false or true, but it does not return the actual true Boolean type. What it does is it returns, when it evaluated this side as true, it takes what it evaluated, the number it evaluated it to, which was 3, and it returns that. So that's not obvious, but we're going to bring up our little window and show that here. So if I have false or 3, it's going to return 3. What if I had true or 3? Here what's going to happen is it's going to look on the left side, it's going to evaluate the left-hand side to true, not a number, but true. It's not even going to look at the right-hand side, because if it's an OR function and this is true, we know the whole expression is true. What did it evaluate on the true side? Well, not a number, but just true. So now we're going to get true. It's fairly simple if you're always working with just true and false constants, but when we have a number here, it's a little difficult. Okay, so let's go on and look at the AND function. What happens when we have 6 and it with true? Well, here we have to, in the AND, evaluate, well, we don't have to evaluate both sides. We can evaluate one side, and if it's false, it doesn't need to go to the other side. But let's see what happens here. The 6 is evaluated and interpreted. It evaluates to 6. It's interpreted as true. Because it's true, the AND function has to go to the other side. It evaluates true as true, and it interprets it as true. What happens here is that it looks true and true, This is the interpreted. This is the evaluated. True and true is true, but what it returns, it always returns the last evaluated expression. So here they're the same, so it's going to return true. Bear with me, it may seem complicated, but and true is true. But what if I did this? True and 6. That's going to give 6. Why? Well, if we look here, it's going to evaluate true. It's got true, it's evaluated to true. It's interpreted as true. Goes to the next side. It looks at 6. Here, 6 is evaluated as 6, but it's interpreted as true because it's a non-zero number. True and true are going to give a true out, but it doesn't return true. It returns its last evaluation, which is 6. So let's go over another example here. True plus 8 minus 2 times false. So what we have here are additions, subtraction, and multiplication operators which take numbers, but we have true and false here. So let's look at the order of precedence. The order of precedence is going to be the multiplication happens first, so it's like we have brackets around here, and then the plus and minus will operate from left to right. So how do we do it 2 times? Because the times assumes a number on both sides. So the 2 is fine on the left-hand side. How does it interpret the false? Well, when an operator requires a number, just as up here, the false is treated as 0 and true is treated as 1. So it evaluates the false to a 0, 2 times 0, and it evaluates that whole expression to 0. Now we have 8 minus 0. We need to evaluate the true. That's going to be converted to the number 1. So what we have is 1 plus 8 minus 0, and that's going to be equal to 9. Let's see if that happens properly. And what you can see here is true plus 8 minus 2 times false gives us 9. So let's look at a couple other examples, try to consolidate this. We'll take this one first, false, and it with 2, ORed with 3. What's that going to give us as a result? Well, first, because of the order of precedence, we know that the AND is done first, and finally, the OR is evaluated. So false and it with true. Let's do that first. False and it with true. Well, in AND, both sides have to be true. So it's going to evaluate the left-hand side. It's going to evaluate false to false, and it's going to interpret it as a false. It's not going to continue to the right-hand side, because if the left-hand side of an AND is false, the whole thing is false. This was the evaluation of the last thing it evaluated was false. So whatever's in the brackets here, it's going to evaluate to false. Now what we have is false or 3. So let's look at what happens. Again, it's going to evaluate the left-hand side to false. It's going to interpret it as a false, and therefore it's going to continue on to the other side, because in an OR function, as long as one side is true, the expression is true. It's going to take the 3, it's going to evaluate it as the number 3 and interpret that. Because it's a non-zero number, any non-zero number is interpreted as true. Well, we have false ORed with true, so the overall expression will be true, and we return what we've evaluated. So this should give us a 3. Let's see if that's true. False and 2 or 3 gives us a 3. Well, let's take a look at our next one here. OR and OR and OR, they all have this, AND has the level of precedence here. So we're going to look at bracketing these terms. So now what we have is 1, 2, 3, 4 terms of which as long as one of these is true, then the whole expression is going to be true. Now we're not actually going to evaluate this unless we need to, because what Python's going to do is Python's going to look at the very first expression on the left, and if that's true, it's going to stop at that point. It's called shortcutting. It's not even going to have to evaluate this. So it's going to evaluate the 0 to a number 0. It's going to interpret it as false. It now, because it's an OR function, has to continue on to the next set of instructions or next set of arguments. Because as long as any of these is true, the whole thing's going to be true. It's going to now have to evaluate what's in the brackets here, false and it with 2. Well, false with an AND function. The first side is evaluated false. It's treated as false. In an AND function, they both have to be true. It doesn't need to go any further. It doesn't need to go to the right of the AND function. So this is going to evaluate 2 false. So right now I have false or false. And now we go to another OR. We go here and we say 2 and it was 0. Well, 2 is evaluated by 2 and it is treated as a true. We're going to AND that. We're going to evaluate the 0 as a 0. It's going to evaluate false. This is going to evaluate false, but it's going to return a 0, the last thing it evaluated, which was the false part here. And so here is what we have. False or 0 or 0. Here, the last thing it's going to go to all these steps, and the last thing it's going to evaluate is a 0, which was false. It's going to return the false value, which is here it's going to return a 0, not false. Well, let's see if this is what we have. And we get 0. Seems a little complicated, so you have to make sure you understand how Python evaluates true and false, and the difference between evaluating it to a number and then how to interpret it as true or false. Multiple comparisons. Again, we have to know how Python handles multiple comparisons. And this is a little unique to Python. It may seem that we're just going to go left to right. 6 less than 8, that's false. And how do we do false less than 7? Well, if false is evaluated as number 0 less than 7, so it seems like the whole thing might be evaluated true. However, that's not how Python handles it, and it's not the way we tend to do things in mathematical notation. Usually in mathematical notation, we're saying here is 8 greater than 6 and is 8 less than 7. You often will see range of numbers like this, written like this. 0 is less than y, which is less than 10. This is a common thing in math, and really what this means is that y is less than 0 and y is less than 10. Well, this is how Python handles multiple operators. So we have to know that Python's going to break this up to this, and it's going to repeat the 8 less than 7. If we had another operator, and it wouldn't matter what it is, any of these comparisons. It's just going to add another block. It's going to take the last one. It's going to AND it, and it's going to do this test. Well, what are the implications of this when we do some examples? Well, first here, let's find out how Python's evaluating this. So we have 6 greater than 8, and we have 8 equals true. So let's try to predict how Python would first evaluate this. Then let's try to add brackets somewhere in here to make this expression true. 6 greater than 8. No, that's false. And 8 equal to true, well, it's going to convert true to a number, which is 1. Is 8 equal to 1? No, and it's going to return a false. And false should give me a false. So this should evaluate false. If we then say, how can we make this expression true? Let's see how this will get evaluated if I put brackets here. Now with brackets, it's going to look at this right here, and it's going to evaluate this first. It's not going to do this step. So it's going to evaluate this and say, okay, I've got to do an equals test. True is going to be 1. Is 8 equal to 1? No, it's going to evaluate false. So now I have 6 greater than false. False, the conditional test has to have numbers on both sides, so the false is converted to a 0. 6 greater than 0, that should return a true. Let's see if that happens that way in our shell. So it did give us false, but if we put brackets here, it'll evaluate true. One last example before we let you go. How's this handled? Well, the plus has precedence over everything else. So if we're going to evaluate this, we're going to get 11. And so this evaluates to 2 conditional tests. So when we have multiple conditional tests, Python's going to break this up this way. It's going to do the first conditional test. It's going to take this number and repeat it. Like this. So is 11 equal to 12? No, that's false. And 12 is not, actually it's just going to stop at this point, isn't it? Because if one side is false, it's going to return a false. So the question is, how can we, with a pair of brackets or adding brackets here, make this true? Well, we're going to show that if we add our brackets here, let's see what happens. The brackets mean we're going to do that operation first. So 5 equals 12, no, that's going to give me a false. Because the plus has a higher order of operation, this is going to be done next. 6 plus false, well, what is false but a 0? Because plus needs a number on both sides. We're going to get a 6 here. 6 is not equal to 7. Oh, that's true. So we expect that with those brackets we'll get a true expression out. Let's try it. So we'll first see how Python is evaluating this. and it's giving us a false as we originally predicted. We think that's going to give us a true, which it does. So these can seem fairly complicated. These exercises are designed so to give you a deeper understanding of how Python is using precedence, order of operation, how it evaluates ands and ors, because it's very a little different than some other languages, and you need to understand exactly what's happening, especially if you're doing an and and or where you've got numbers on one side and true and false on the other. And how does it handle multiple comparisons? You may need to go through this video a couple times to sort of get this straight.